Okay, so we're looking at another representation of data that we've seen before in the junior school. So it's called stem and leaf plots, and basically there's one number in the stem and the other number is in, so there could be more than one number in the stem, sorry, I beg your pardon, but there's only one number in the leaf. So we'll have a look at an example maybe where there's more than one number in the stem. Okay, so it's another way to represent data. Okay, it's like looking at it as a graph, and it's looking like a histogram. So a normal histogram is like this, up and down, but with a stem and leaf, you could imagine that you're actually seeing the data this way. So it looks like that, but it's just another way to look at data. Okay, so all the original data is retained, so you can still read the scores, and you can obviously find ranges and interquartile ranges and things like that. So here's an example where you've got the weights of possums. Okay, so you've got 1.8 kilos, 3.2 kilos, 0.7 kilos. So the first number is a 1, the first number is a 0, and the key has to always be given to you. So they have to tell you what the numbers mean. So 0/7 means 0.7. Because like for instance 1/7 in this particular data could be 1.7, and 1/7 in another set of data could be 17. So they have to tell you what the scale is. Okay. So what you've got is you've got the original data still here. So there's your 0.7 kilo possum just there, and then your 0.9 kilo possum is just there, and say for instance your 3.2 kilo possum is just there. So you can still see, okay, this is all arranged haphazardly, but here you can see that the smallest possum was 0.7 and the biggest possum was 3.2. So you can still see all the data is still there, and from there you could find, you know, the range, or you can find, you know, Q1, Q2, Q3. You can just have to do it manually, which we'll see in the next example. Okay, so come across when you're ready. Okay, so every stem and leaf must have a key attached, so you have no doubt what the meaning of the entries are. Okay, so in this particular one, again, we've got decimal places, but this time, instead of having a class of 10, we can have a class of 5. And what we do is we put asterisks. So for instance, 0 asterisk is 0.7 and 0.9, but if you had, say for instance, a 0.2 kilo possum, you'd have just 0.2, and then the asterisk just mean it's the top end of the scale. So you've got 0.7, 0.9, 1.1, 1.4, and then here are the big ones. Here are the big possums in the 1. So just another way to break it up in your data sets. Okay, so when you have an asterisk, it was the higher ends of the scale. So this 2 here is 2.1, 2.2, 2.2, 2.3, 2.3, and asterisk is the top end of the 2s, so 2.5, 2.7, 2.7. Okay, again, they have to give you the legend when you do it. Okay, come across when you're ready. Okay, so in this particular question we have to find the interquartile range, and so first thing you have to work out is how many pieces of data. So there's 30 pieces of data, and so to find the middle of 30, it's an even number, so it's the 15th and the 16th score, and then you just have to manually count through until you get to the 15th and 16th score. So they were both 179s. Looking at the scale, we're measuring in the hundreds. Now this is an example where this time the stem has 2 numbers. Okay, so the leaf can only have the last digit, so the 4 or whatever, and then these time your stems have 2 numbers. Okay, so 154, 158, 158, 181, 201, 200 and 202. So with finding the interquartile range, you've got to find Q1, Q2 and Q3, and you just have to do it manually. Work your way through the data set, you know, find your Q2 first, which was going to be 179, and then you draw a line down the middle and you go backwards to find Q1, or go forwards to find Q3, and then the interquartile range is just the subtraction of those numbers. Okay, so there's no shortcut. You've still got to do the hack work to find the numbers for your Q1, Q2, Q3. And then the interquartile range is just interquartile range is just Q3 minus Q1. But there's no shortcut. You've just still got to work your way through it. Okay, copy and come across. And the last thing we can do with is comparing excuse me, back-to-back stem and leaf. So the stem is common, and you read forwards for brand X. So again, the scale says that the brand X, the lowest number is 69, but for brand, this other brand, you have to read this way, and so the lowest number, so the ordinary brand, the lowest number is 60. So the trick, obviously, reading on the left-hand side, the left-hand side is a little bit harder because you've still got to arrange your numbers from the stem outwards. So note, you can see how the numbers are getting bigger, 0, 0, 2, 6, 8, whereas on this side the numbers are going bigger that way. So you've got to reverse the way you write your numbers for the left-hand side. So that's the only trick with the left-hand side. You've got to work your way from the stem outwards. So there's information up here just saying the same thing. So if you're trying to find the range for brand X, brand X, take the pen back. So for brand X, it's 60, and the highest number is 114. That's the highest number, so it's 114. And on this side, the highest number is 146, and the smallest number is 69. So the right-hand side is a lot easier to work with because you're reading left to right, but here you've got to read right to left. Okay, and then obviously you can answer questions about who's got the biggest range, is the data normally distributed, or is it whatever. So you can still do lots of questions by comparing the shapes and things like that. Okay, that's it. Thanks for coming. Bye.